Well, I started stripping the bonnet and the boot back. Used paint stripper and then a Brumby wheel, and it's all pretty straight, pretty good. I may put a couple of little bits of weld just in the corners here. There's a slight split there. There are a few little marks here, a couple of little very slight imperfections there that I need to knock out. And just here on this side there is a very strange sort of dent. Can't describe it any other way, that has been whacked, and that had a little bit of filler in there. And on the other side too there's a little bit of denting there. So unfortunately I am going to have to put a little bit of filler in this because I can't get into the other side to knock the dents out. There's a brace in there on both sides, so I'm going to have to go with that. But it's pretty good, really. Certainly a lot straighter than my MGA bonnet. And here we have the boot, which also comes complete with quite a few dents. Somebody's worked on this before. It has had a luggage rack fitted to the back, and somebody's filled these holes in, welded them. They're not done brilliantly, but they're okay. I don't think I'll bother redoing them. The welding looks fine. There are a few dents I can knock out. There's quite a large one there which will come out alright, and a few small ones. It actually looks worse probably on the camera than it really is. You can see all those little dents across here. This had quite a lot of filler in it before when I stripped it, which surprised me because again it looked pretty flat. You just can't tell until you get the paint off. Some of these dents, this is a weld here where the luggage rack was, but no, actually that's a dent. Some of these dents around the periphery I can't really repair unless I remove the inner bracing, which I don't really want to do. So some of those little dents will get a little bit of filler in them. They're not too bad. They're quite clear to see. I've just gone over this with some 80 grit paper in one direction, which shows up all the imperfections in it, but as I say, it does look worse than it really is. Well, I thought I'd move away a little bit from the bodywork and the mechanical work I've been doing on the car and have a go at trying to repair this water temperature gauge. Now, these water temperature gauges work on the principle of a burden tube, which is really just a flattened piece of tube in a bit of a curl like this, and the tube is pressurized with a vapor, which in this instance happens to be ether, and tries to straighten up, and as it straightens it moves the gauge. The oil pressure gauge works on the same principle as that. The problem, of course, with them is that the pipes often get severed. There is a pipe which runs, a very fine pipe, this one here, which runs up to the back of the gauge in here, and you can see this one is broken off actually at the gauge head. I've cleaned this up a little bit because I'm going to resolder it. So the first job I've got to do is drill this out, clean this up, and resolder this section back into there. So this is a very fine, I'm not sure whether that shows up on camera, a very fine capillary tube. On the other end of this is a brass bulb which is filled with ether in a liquid form. The boiling point of ether is about 34.6 degrees Celsius, I think. So this goes into the water jacket, and then as it comes up to the boil, it pressurizes the, it sends vapor, it turns to vapor, sends it up the tube, which then pressurizes the burden tube at the end of the gauge and causes the needle to move. They get severed through old age, or sometimes people cut them thinking that they're wires. And of course the ether is then lost, and ether's a bit difficult to get nowadays. So I found some stuff on the internet which talks about repairing these and talks about using a donor gauge. So I bought this donor gauge here, which only cost me about $16 or something off the internet. So I figured that if this doesn't work, it really doesn't make a great deal of difference. What I had intended to do initially was to solder the pipe from this gauge here into the back of the other one, but I can't do that because this pipe is much smaller than the original gauge, and also this sheathing around here isn't correct for the period. So what I've decided to do is to try and take the ether out of this bulb here and inject it into this one there. So I'm going to be drilling a small hole in the end of here after I've soldered that in, and I'll run some air into there just to see if it works under a little bit of pressure. And I have here clearly a hypodermic syringe. This isn't as deadly as it looks. It has a drawing up needle on the end which isn't very sharp. So I'll drill a hole in here so that I can draw this ether out, and then I'll have another hole in here which is very small, just big enough for the needle to go in. We'll put the needle in there and inject the ether back in there, and I have to move fairly quickly so that the ether doesn't boil away. I also have to be careful because ether is highly flammable, and it's an anaesthetic as well. It sends you to sleep. So if I suddenly have an impromptu snooze on the shed floor, that'll be the reason why. What I'm going to do before I resolder that back into the old gauge is I'm going to prepare an ice bath into which I shall put this for a short period of time with some ice and some salt, just to really chill it down and make sure that the ether is in a water form. I have to solder this together with a soldering iron, not a flame obviously, otherwise the thing will launch itself across the shed like a rocket ship. I have an 80-watt soldering iron. I'm not sure whether it's going to be powerful enough. I hope it is. But if I make the hole very small here, just big enough for the needle to go in, and I might make up a little brass plug to put in there first as well, just so I don't have to work quite so hard with the soldering iron. So I'm off now to prepare an ice bath and to do a little bit of soldering on the old unit.
And inside this particular gauge, this is the dual one, you can see the two little pins there that the pointers fit on, and then we have the oil pressure gauge here, and the real one is the mechanism that works the water temperature. Very compact, they're both pretty well identical. And just as a matter of interest, this is the inside of a Borden gauge. This is an oil pressure gauge, but the water temperature is exactly the same. So here's the flattened tube that I was talking about. I might do this with one hand, but if you see, as this tube moves, if that tube is stretched, then it just allows that pointer there to move, which, as I say, in this case is the oil pressure. So they're a very clever little design, and that's the bit that makes it work. So the pressure comes in the back here, and fills up this flattened tube here, which then tries to straighten. Still in use today in some areas. A brilliant little bit of engineering design, very simple but effective.
Okay, so this is the donor gauge in a ice bath. This is the old gauge. I've soldered in the pipe back into the back of this. I hope that soldering joint is okay, and I hope I haven't got it too hot so that it's melted some of the solder inside. I used a flame on this solder joint because there's no ether involved, so that was okay. I've drilled a small hole in the end of here, which probably isn't visible from up there, and what I'm going to do after I've put the ether in here is to put a little brass screw into there and then snip that off and solder it. I'm really just using this as a little plug to give me a little bit more time. I've got some solder here, some flux, and my soldering iron, and this is, I'm not sure whether that's going to be hot enough. That's one of the problems I'm up against. So I'm a bit anxious about all of this, but let's see what happens. So the first thing I'm going to do, I'll get the syringe ready, and I'll try and get the ether out of this donor gauge. Probably don't really need that ice anymore. Hard to know where to drill this actually. I might take this one out of the vise and put that one in the vise. I think it might make it a bit easier to drill. So I'm trying to draw the ether up. There doesn't seem to be very much in here. I'm not quite sure. I think there's only a couple of cc's normally. Not all that easy to do, but it is sort of working. Certainly not as straightforward as I had hoped it would be. It's a bit hard to know how much is in here, but there certainly doesn't seem to be very much. And it would appear, now that I have it all out, I'm very dubious about whether this is going to work, to be honest, but we'll see how it goes. So I've pulled that. I'm hoping all this is showing up on the camera because I can't operate with two hands for it. So I've got what I believe is just about all of the ether out of that, and put it into the other tube. We'll just see what happens here. I've got to let's get that out of the way. So now I just have to snip off this little screw head here. I had a small file. I'll clean that up a bit with a file. Should be that. That can now go into the vise. The putting the screw in there just gave me a little bit more time. But I think getting the old ether out is a bit of a problem. I'm not really convinced this is going to work. I'm not sure how much ether, I'm not sure how much ether there is supposed to be in here. Probably only a couple of cc's, I guess. But yeah, I'm sort of shooting in the dark a bit and making this up as I go along. So we'll see what happens. I don't even know, as I say, whether this soldering iron has got enough heat in it to solder this. Let's see what happens here. Well, there's a bit of good news and a bit of bad news. Unfortunately, most of it's bad. It did work, but it only really comes up to about 100, it's gone down a little bit now, but it only comes up to 120, 140 degrees in boiling water. So the idea was good. I think possibly the main problem is that there just isn't enough ether in the bulb. And that's, I could try and get some ether from somewhere, which I think could be a bit of an issue. Anyway, it cost me about $15 and a bit of time to do that, and it's a bit of fun, and I'll have a go at most things. So I might not give up on this just yet. We'll see what happens.